What we're going to take a look at here is factoring quadratics. And you notice we're going to have 6 examples that we're going to go through, all of which could really fit into a different category, because when we look at quadratics, what we have to think about is what category does it fit into? Does it have a GCF that we can remove? Is the a value equal to 1? Is a value not equal to 1? Do we have a binomial? Is there a special pattern to it? All of these things have to go through our heads every single time that we look to factor a quadratic. So the first thing we always want to do is we want to identify if there's a GCF that we can remove. GCF would be some constant that is multiplied by all 3 of the terms, or 2 of the terms if we only have 2, like we do down here. Looking at this side, there is no GCF, and what I notice is that my a value is equal to 1, so I'm going to go through my process for factoring those kinds of expressions. What I notice is I have a plus term in front of my 20. So when I go through and I do this, I can use that term to identify that I'm going to have x plus something and x plus something here when I actually go through and I factor this. Now, what we're actually looking for, we're looking for 2 numbers that multiply to 9, add to 9 and multiply to 20. So 2 numbers that multiply to 20, add to 9. So what I want to go through and do is list out all the factors of 20. 1 and 20. 2 and 10, 4 and 5, and then also their negatives. So I could say negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. All right, all of these numbers when multiplied together are going to give me positive 20. Now I have to go through and look and see which of these numbers when I add them together is going to give me 9. And I see it's going to be these 2, positive 4 and positive 5. Which then I should be able to insert right here, which makes sense. 4 times 5 gives me 20, 4 plus 5 gives me 9. So these 2 binomials are the factored form of x squared plus 9x plus 20. And I'm really going to go through and do the same thing here. What I notice, again, I have an a value of 1, so I can set up 2 binomials here. I have a plus sign in front of my c, so I know I'm going to have the same sign in front of both of my terms, and in this case that is going to be minus. I should have x minus something, x minus something. And again, I'm looking for 2 numbers that multiplied together give me 9, and when added together give me negative 6. So I can go through and list out all the factors of 9. I could have 1 and 9, I could have 3 and 3, and then I can also have the negatives. Negative 1 and negative 9, and then negative 3 and negative 3. Alright, all of these terms multiplied together give me positive 9. Positive 9. Now I'm going to go through and look and see what of these values added together gives me negative 6. It would be negative 3 and negative 3, which fits this perfectly. X minus 3, x minus 3. I went through 2 numbers, negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Let's take a look at these next ones. Now, looking here, I have a binomial. So there's 2 ways that I could look at this. 1, I want to see if there's a GCF. There is not a GCF between these 2 terms. The second thing I want to think about then is just changing the form. Alright, I change this to a trinomial, just saying b squared plus 0b minus 81, because that's really what this is saying. You know, if there is no b term here, it's just 0 times b. And I would go through the same process that I did up here. I have an a value of 1. Now what I have to be aware of, my variable is not x this time, and it's not always going to be. So when I go through and I start the factoring process, I have to consider that what my variable is. Alright, it's not always going to be x. So now when I look at my trinomial here, I have a negative sign here. So what that's going to tell me is I should have a plus and a minus when I go through on these factors. It should be b plus something and then b minus something on the other side. Same process as before. Find 2 numbers that multiply to negative 81. I could say 1 and negative 81. I can say 3 and negative 27. I could say 9 and negative 9. And there's really nothing else. And I could go through and say 81 and negative 1, 27 and negative 3, and then 9 and negative 9 would really be the same thing. So looking at this here now, if I went through and I did this, the only two numbers that add to 0 would be 9 and negative 9. 9 and negative 9. So it fills all of that out. Now, what you could also do, this is a special pattern. Alright, what the special pattern means, if we have a binomial, and where if we have ax squared minus b squared, if it's in this format, x squared minus some constant here, I'm sorry, I should just say ax squared minus b. Now, if it's in this format, and sorry, if it's in this format and both a and b are square numbers, so they're 1, 4, 9, 16, 25, so on and so forth, we're going to be able to write this in a shorter way. We're going to be able to kind of cut out this entire process and just say, alright, we're going to take the square root of b, and that's going to be put as both of my factors, and then on this side I would put the square root of a times x. Square root of a times x. I know it's kind of sloppy and small, but looking at this example here, this is really 1b squared minus 81. So looking at that, 1 and 81 are both square numbers. This is 9 squared, and that's just 1 squared. So what that means is if I really wanted to take a little bit of a shortcut, when I see that pattern, what I can end up doing is saying, alright, well, I know b is my variable. I know I have minus in front of that last constant, so I'm going to have a plus, and I'm going to have minus. I'm going to take the square root of 81. Let's say 9 and 9, and I would take the square root of 1, and that would end up being my constant in the front. So looking at that, it's the same exact thing that we had before. So if we had, for example, something like 4x squared minus 9, looking at this is going to fall into a special pattern as well. I have a square number here and a square number here. So if I went through and I factored that, what I would end up going through and doing is, the square root of 9 would be 3. So I'm going to have plus 3 and I'm going to have minus 3. Now when I take the square root of this, it's going to be 2x and 2x. Alright, and this is something that we'll end up going through and proving why that ends up working in class. Okay, let's kind of separate a few of these. Okay, next example, 5y squared minus plus 5y minus 10. Looking at this, the first thing I see is that I have a GCF, and my GCF here is 5. So the first thing I want to do is remove 5 from each of those terms. So I factor 5 out here, factor 5 out of there, factor 5 out of there, and I'll write that right in the front. Now, from here, everything that's left over, the y squared plus y minus 2, I look and I see, can I go through and factor that? So what I notice is I have an a value of 1, so I'm going to try my method that I had done up here for these two examples. I'm looking for two numbers that add to 1 and multiply to negative 2. So what I can set up, I have subtraction at the end here, so I should have two different signs. I should have y plus something and y minus something. I'll list out the factors of negative 2. Negative 2 and 1, and really only negative 1, 2. I just found the opposites here. Now I got to think about what adds to positive 1. These two. Alright, negative 1 and 2. They are the two numbers that multiplied together give me negative 2, but when I add them together, they give me positive 1. So this would be my factored form of the expression. Alright, last two now of these 6 examples. So looking at these now, these are going to be the most complicated, and this is the process that we had talked about in class. So looking at these, I have a values that are not equal to 1, and I don't have a GCF that I can factor out. What I notice over here is I have an a value that's equal to 2. So now, what we're going to go through and do is that process that we talked about when we have an a value that's not equal to 2. What that consisted of, you take that this a value is equal to 2, and you multiply it by c. So I would say x squared plus 7x plus 6. I did 2a times c here. Now, I go through and I factor this, just like I would any other way. Two numbers that add to 7 and multiply to 6. So when I go through and I do that, I can list out all the factors, and it's going to end up giving me x plus 6 and x plus 1 when I go through and I do that. Now, what we have to do is we have to consider this a value equal to 2. So that ends up coming back into the picture. How it does. We divide these terms by 2. We divide the factor by 2. If it simplifies like it does here, 6 over 2, I can reduce that to x plus 3. Alright, 6 over 2 is just 3. 1/2 doesn't simplify anymore. So, if we remember from class, what we end up doing is we take the 2 and you move it as a coefficient in front of that x term. Alright, and then we change that into 2x plus 1. So what that's telling me is if I went through factoring this expression, this is the factored form of that. And what I'll do right now is I'll go through and I'll check this. And this is something that you could do for every single one of these. You can go through and distribute through and multiply using that trick, foiling, that everybody loves to use. I multiply the first terms, multiply the second term, or outside terms, inside, and last terms. When I multiply these two together, I should get 2x squared. Multiplying the outside terms, x times 1 gives me x. Multiplying 3 times 2x gives me 6x. Multiplying 3 and 1 gives me 3. Now when I go through and I combine my like terms, I get 2x squared plus 7x plus 3, which is the same exact thing that I had up here. And it should be that way. If it doesn't come out the same exact way, then something went wrong in your process. So this would be my factored form. X plus 3, 2x plus 1. Just go through one more when we have an a value that's not equal to 1, just to show this process one more time. What I see, my a value is equal to 3, so what I'm going to do is I'm going to multiply a and c. I would have a squared minus 17a plus 30, and I'm going to go through and I'm going to factor this. And again, just to call attention to it, what we have to remember is always check the variables. Right now we have a variable of a, not x, so our answer, we should continue using a. So, looking at this, what I should see is I have a plus at the end, so I should end up having the same sign for both of these, and that sign is going to be subtraction. So I can go through, list out all my factors of 30, and think about which two are going to give me what two numbers are going to multiply to positive 30 and add to negative 17. Those would be negative 2 and negative 15. Now, just like in the last example, we have to bring back in the fact that we had an a value of 3. And what we do first, we divide these factors by 3 and see if we can simplify. On the right hand side we can't. 2 over 3 cannot reduce anymore. So what we end up doing is we move the 3 as a coefficient into the front of our a value. And then on the other side I have 15 over 3, which does reduce. So what that ends up giving me is 3a minus 2 and a minus 5. So that would be our factored form of that